Hello everyone. For the lab part of my course, PHC 306, Microprocessor and Microcontroller, I am working on graphical LCD module using 8085 ADLCD. Sorry, my camera isn't working because I have some issue with my laptop. So yeah, coming with the aim. So firstly, what I'm doing here is I'm displaying a horizontal moving line instead of a basic text, which was actually in the lab manual given to us. So firstly, I had while performing the experiment for the first time, I had displayed a basic text in the center of the screen and with a square line border. Okay, so for the innovation part of the experiment, what I thought was of displaying a solid line which moves up and down. So yeah, so the total apparatus that we have used was a microprocessor kit 8085 ADLCP, a graphical LCD module, and a 26 FRC cable pin. So talking about the program, so the program simply generates a real-time animation instead of a static text. So it works by selecting different page addresses of the graphical LCD, where each page address is assigned to a particular row of LCD, a particular horizontal strip of LCD. So after that, we write the data FFH, which is the full, the maximum value across all the columns to form a solid horizontal line. So after displaying the line at a given position, a delay is introduced so that we can actually it is visible to the human eye. Following that, we clear the screen to remove the previous frame. So yeah, so talking about the actual code. So firstly, we start with the initialization part of the program. Here, the stack pointer is set to a safe memory location. This is important because my program uses multiple subroutines, and without a properly initialized stack, the call and return instructions would not work correctly. After that, I configure the 8255 programmable peripheral interface. This step is necessary because the 8085 itself cannot directly drive the GLCD. So the 8255 acts as the interface between them by sending the appropriate control word. So yeah, then I send some initial commands to the GLCD. These commands basically turn on the display and prepare it for further instruction from me. So yeah, coming to the second part is the main control loop. So yeah, after initialization, the program enters the main loop, which is responsible for running the animation continuously. Here, the register is loaded with the number of pages available on the GLCD, which is 8 in this case. Here, the pointer is also initialized to a memory location where the page values have been stored. So these loops keeps repeating indefinitely, so that the animation keeps on running infinitely until it is stopped by a manual force. Yeah. So coming on to the movement of the line, the GLCD is divided into pages, right? So where each page corresponds to a horizontal strip of pixels, as mentioned earlier. So instead of moving the pixel by pixel, which would be complicated, I simply change the page address. So in each iteration, a page value from the memory is fetched like B8, B9, BA, or something like that, like B3, and so on, and it is sent to GLCD. Each of these values corresponds to a different vertical position. So on the whole LCD display. So as the program cycles through, these values appears to move from the top of the screen to the bottom of the screen. So this is how the vertical movement is achieved on the LCD display. So yeah, the column initialization. This determines where the drawing starts horizontally. So in my program, I fix the column to start the value and usually from the left to the right of the screen. So this ensures that every time the line is drawn, it begins from the same position and extends across the display entirely. Coming to the fifth part, drawing the line. So now actually displaying the line, the horizontal line. So to do this, I run a loop across all the columns of the selected page. In each iteration, the value is set to FFH, that is the maximum value to the display. So FFH means all the bits are 1. So all the vertical 8 pixels in that column will be turning on. So when this is repeated for multiple columns, it performs a continuous horizontal line across the whole screen. So yeah. After that, we introduce a delay. This is very important as the 8085 executes the instructions very extremely fast. So if this isn't added, the line would move so quickly that it wouldn't be very visible to us. So yeah, so this delay is implemented using a loop that simply wastes some processor time. So by adjusting this delay, we can control the speed of the animation by making it faster or slower as needed by us. So yeah, once the delay is over, the screen is cleared so that we can move on to the next page. Yeah. So effectively, every pixel is turned off. So yeah, for moving to the next page, this is done by incrementing the pointer to get the next page value, and decrementing the counter. Then the program repeats the same process again and again. So the line shifts one step at a time across the screen. When all the pages are covered, the loop starts again and creating continuous animations. So, subroutines. The program also uses few subroutines to make the code cleaner and organized. There is a command routine to send controls instructions to the GLCD, a data write routine to send pixel, and a delay routine to the control timing. Using subroutines here has avoided repetitions and makes the program easier to understand and modify, to be honest. So at the end, the overall program works in a cycle. So it selects a page, then draws a horizontal line. It waits for some time, clears the screen, and then moves on to the next page. By repeating this continuously, it creates the effect of line moving continuously vertically across the GLC. So yeah, thank you.